Good morning, good afternoon, and welcome back everyone to Couch to Coder. Today's episode 6, is going to be covering Pandas, which is the first real data analytics tool that we are going to cover in this series. Pandas is going to use a lot of the concepts that we've learned earlier, as well as some new concepts, and we are going to actually be looking at Pandas again from a problem. I feel like that's the best way to learn. So the problem we're going to have today is we're going to be given a large Titanic data set. Go ahead and open this guy up. We'll discuss it in a little later, and we have some objectives on it. So we're going to try to count how many men and women were on the Titanic. We're going to figure out what the average age of the passenger was on the boat that survived. What about the average that didn't quite make it? What was the average price people paid in each class, being first, second, and third? We're going to change those prices, so do a little bit of data frame manipulation and change those prices to terms of 2020. So scale the pricing. And then we're going to see what percentage of men made it out alive, what percentage of women made it out alive, and then lastly, what percentage of people made it out alive per class, meaning your first class, your second class, or your third class. So we'll go ahead and hop right in. We'll look at the Titanic CSV. So what's great about Anaconda is you have a CSV viewer, and for those of you who aren't aware of what a CSV is, it's a comma separated values sheet. Basically, it's a very simple macro disabled, code disabled Excel document. You can only have one page, but CSVs are a very efficient way to store information, and they're stored essentially like a text file. So they're very light and very easy to work with. So you can see that we have a passenger ID, a survived, a passenger class. So this would be first, second, or third class. The name, the gender, the age. Not quite sure what the SIB SP is or the parch, but we have the ticket or the ticket number, how much they paid to be on there, what cabin they were in. I guess some of them are unlisted, and then embarked, whatever that variable is. I'm not really planning on using that. So the variables I'm not entirely sure of, we're not really going to use them. Alrighty, so first thing we need to do, we are working with pandas, so we're going to import pandas, and I'm going to import it as PD. That's kind of the industry standard when working with pandas. Essentially what this means is when you call anything from pandas as opposed to writing out pandas every time, you can now write out PD. So the first thing we're going to do, we're going to call it we'll call it we'll call it Titanic data frame, and we're just going to read in the CSV, so pd.read CSV of, you got to give it the full name, so titanic.csv. A great tool, something that I really recommend as opposed to looking at the whole data set. You can do this nice little operator here, a dot head. You can see that you get just the first 5 indices on here, and we filled in our blanks on the cabin with nans. So that is how they are actually stored within this pandas data frame. Alrighty, so now we need to count how many men and women were on the Titanic. So there's a couple ways to go about this. I'm going to single out the data set to where we have a male data set and a female data set. So we're going to go about that by saying Titanic data frame of, and we're going to say Titanic data frame of sex is exactly equal to male. Nope. We need some quotes there, and we're going to call this the male data frame, and we can use this same exact thing and call it the female data frame. All right, so now we have a male data frame and a female data frame, and let's go ahead and do a dot head of the male data frame like before, and see And you can see that under the sex column, we only have males. So let's talk a little about what I did here, exactly what's going on, and how this works. So just like our list, when we're calling out an indice of, say, my list, and you're indexing out the 0th element, how data frames work is you can index out on trues and falses as well. So right here, if we were to type out just this, Titanic data frame of sex equals male, we can see what this looks like. You'll see that you only return trues and falses, and that those trues and falses are actually aligning with the male true, the female being false. So since we're indexing on trues and falses, so we're getting rid of all of the indexes that are falses from the Titanic data frame, we're left in the top one's case with only males, in the bottom one's case only females. So that's exactly what's going on here and how we are able to actually get a full male data frame and a full female data frame. All right, so now we just want the length of these data sets. So we'll say m length is equal to the length of the male data frame, cap that guy off, and f length is equal to the length of the female data frame. Alrighty, and we'll just go ahead and hit a print statement and say there were an m length men on the Titanic, and we'll hit another print and say there were blank women on the Titanic. Alrighty, so if we run this guy, you'll see there were 577 men on the Titanic and only 314 women on the Titanic. Interesting. I wonder what makes up for that. I'm assuming a lot of the men were with women, so maybe this accounts for children. Maybe there's just a lot of men, children, I guess boys on the Titanic, or maybe some guys were on business trips. Who knows? So that makes the first objective done. Count how many men and women were on the Titanic. There it is. So next, what was the average age of passenger on the boat that survived? How about the average age that didn't make it? So now we need to use a very similar concept to here, but as opposed to filtering by sex, this time we're going to filter if they survived. You can see survived is listed as a binary, 0 being no, 1 being yes. So we're going to go ahead and post this guy here. We're going to say survived, because that is the name there. And we're going to say 1. And we're going to call this the survivor data frame. And we'll run this guy, and we'll do the survivor data frame .head just to show what we're working with here. And you can see that everyone here has survived. So what was the average age of the passenger on the boat that survived? So we're going to take, we only want to work with the age here. We don't need any of the other columns because we're not asking the average age of everyone named, say, Lisa that survived. We're just looking for the average age. So we're going to filter down to our survivor data frame age. You'd see we only get the age and the index of the age, and we're just going to take the mean of it. The average age of the survivor was 28.34 years old. So we can do the same exact thing for the non-survivor. So we're going to call this the non-survivor data frame. We're going to change that variable equal to 0. And then we are going to say non-survivor data frame of survived. Oh, shoot. We don't want survived. We want their age. And then we want the mean of that. You can see the average age of the passenger that did not make it was 30.6 years old, 30.63 roughly. So a little bit of an age discrepancy here, given that there were only, let's see, there was only about 900 passengers on here, so it could be by chance. I mean, you figure the younger people probably are going to have a higher chance of making it in the water for a while. So if we have anyone, really old on there, then that might be the reason. I mean, we can always count. So let's see, older passengers data frame. We'll say that that is the Titanic data frame of the Titanic data frame is of age, and we'll say that's greater than or equal to 65. So saying, our older passengers are greater than or equal to 65, and let's just see the length of that. Oop. And the length of the older passengers, oops. So there were only 11 people on the Titanic that were older than 65. Now granted, this did happen in 1912, and this did come out of Great Britain, so you figure the life expectancy then wasn't quite as high. So maybe we'll change this down to 50. I know 50 is not very old, but there were 74 passengers on the Titanic that were over the age of 50. So maybe these people were just a little hung out to dry when they had to stay in the water. So we have, what was the average passenger on the boat, average age of the passenger on the boat that survived? How about the average age that didn't make it? We have now completed objective number 2. So objective 3, what was the average price paid in each class? So again, we're going to go to a very similar filtering process, and we are going to filter out by each class, so P class equal to 1, 2, or 3, and then we will be taking the mean of their fare price, so how much they actually paid. This one's interesting. This person paid a half of a penny. I guess that was in the era of when people still did that, so we'll go ahead and filter on P class then. So again, Titanic data frame of Titanic data frame of P class exactly equal to 3. So this would be our third class people. So we're going to call this class 3. We'll do the same thing and just go the second class, and then lastly the first class. Alright, so now we have our first class, our second class, and our third class, and our class 3 length is equal to, actually we want the length of class 3. Alright, and we will go ahead and do this for the rest of them, and we'll be able to actually see how many people were in each class. How many people were able to afford first class, how many people were not. And we'll be using this to calculate the percentage of people that were actually able to make it out from each class. So obviously to get a percentage you need the overall as well. So we have, there were 216 people in first class, there were 184 in the second class, and there were 491 people in the third class. So you can see that there's kind of a weird disparity between there. In the next episode we're going to do a matplotlib. We're going to be plotting these and actually looking at all of this data and visually seeing exactly what's going on. Alrighty, so we have the data frames of the people in each class, first, second, and third class. So now we need to actually take those data frames and filter out those who survived. So we'll take our class 3 and then we'll say of class 3 of survived is exactly equal to 1. And we'll go ahead and take this and call this class 3 survivors. Actually, we'll just abbreviate that, make it a little easier. So we'll say class 2 and then class 1. Just got to change these to 2, change these to 1. So now, if I show you one of these data frames, so we'll just take the class 1 survivor. Nope. Got to run that first. You can see that we have all people that paid a relatively high fare that were first class. And now we are just looking to see the length of these guys. So let's see if we take the length of our class 1 survived, the length of, actually we'll just take the copy from there, and lastly the length of this guy, and we'll call this the survive 3 length. Why not? This isn't the best variable formatting, but that's okay for now. Alright, so now we have the third class length, the second class length, and the first class length of who survived. So now we just need to put together a nice little print statement and say in the first class, and then we want the survive length over the first class length percent of people survived. So if we run this, we should get in the first class 55% of people survived. Okay, so if we run this same exact thing, but change these guys to second, in the second class, 47% of people survived. And we will change this to the third class. Alrighty, and in the third class, only 28% of people survived. So that's a pretty big jump, a jump between 55% survival rate to 28% survival rate. So if we're taking that 55% of, see how many people we had, then, I mean, you're talking almost as many people survived that were in the first class that survived in the third class, and there's 4 times as many people in the third class. I guess that's not quite right, but still, that's pretty rough. All right, so I guess while we're at it, what was the average price people paid in each class? So first, second, and third. So we have all of our classes, class 1, class 2, class 3. So all we need to do here then for this guy is class 1 of fare, and then just dot mean. So the people in first class on average paid $84, or I guess it would be euros in this case if they were coming out of Great Britain. So we're going to be the class 2 average fare was $20, and the class 3 average fare was $13.67. So the last, or not the last, but the next is change those prices to numbers in 2020's terms and then do the same again. So see the cost disparity after we change the prices in 2020 terms. So there's a couple ways we can go about this. We can change our whole data frame, our whole large Titanic data frame to 2020's numbers, or we can change each of these individuals. So if we're doing the same again, it might make more sense to change each of these individuals. So what we're going to do is we're going to say class 3 of fare is going to be equal to class 3 of fare times, and then we need to figure out exactly the multiplier of 1912 to now. So I'll go ahead and open a Google tab and say price of euro in 1912 to today. The inflation rate, the cumulative price change was 2,543%. So we are going to take that 2543.19 and multiply it here. So 2543.19. Alrighty, so there has to be a better way, it says. So let's figure out that. So how to multiply a column in Pandas. Use the multiplication operator, it says. So that's exactly what it says. It says you should do it just the way I did. Alrighty. Well, we're going to leave it there then. Ignore this little error. And we will be doing the same thing for each of them. So we'll go ahead and change this to class 2, class 1, and then class 2, and class 1. Alright. So now, if we take the class 3 fare, we see that the average fare to travel on the Titanic in the third class was $34,779 in today's numbers. Does that sound right? 2543.1319. Whew. That's quite high. Alright. Can only imagine what second and first class is then. Second class, so it jumps up to a $52,000 change. Wow, okay. In the first class fare, oh geez, I can only imagine, is $214,000 to get on the Titanic. That is quite a lot of dollars. Now I understand that we were talking about the upper class here and money doesn't quite scale the same, but if we were to do 1912 to today, then that's a large price range. Alrighty, so we know what percentage of men made it out alive as opposed to women, and what percentage of people made it out alive per class. So we got the what percentage of people made it out alive per class. And the men and women, I'm going to go ahead and leave it. This is a great problem for you to take and figure out. Use very similar filtering methods as we did before. So in this lesson, in total, we covered filtering with a Pandas data frame. We used the mean operator. You can also use other operators like median and sum. We covered how you can actually change the values within a data frame, and we showed you exactly how data frames are scaled, are compared, um, and some easy ways to look at it with data manipulation. Alrighty, well, I hope you enjoyed this episode. On the next episode, we're going to be visualizing some of this data with matplotlib, which is the most commonly used MATLAB transferred visualization library into Python. All right, we'll see you there.